output or outputs depend upon the present state of combination of inputs. So dito is the most fundamental building blocks of combinational circuit. So yung more complex combinational circuit is yung adder and subtractors, multiplexer and demultiplexer. Okay, magnitude comparator, etc. So, however, a for said combinational logic function and many more, including more complex one, are available in monolithic IC form. So, yung more complex combination circuit may be implemented using a combination of this function available sa IC form. So, sa chapter na to is cover natin yung device we use to perform arithmetic and other related operation. So, ito yung adder and subtractor, yung sinabi ko kanina. And, the text has been adequately illustrated with the help of large number of solved problems. Yan yung ating about sa arithmetic circuit. So, simulan natin sa combinational circuit. Ano to? So, ito ay sa one where the output of any time depends on the present combination of inputs, and that point is the time with total disregard to the past state of inputs. So, the logic gate is the most basic building blocks of combinational logic. Kaya natin pinag-aralan yung gates. And the logic function performed by conventional circuit is fully defined as Boolean expression, ito tinatawag na sequential logic. So, compromise both logic gates and memory elements such as flip-flops. So, ito yung kanyang figure, generalize. Meron tayong n input na variable and n output variable. So, there are 2 raised to n possible combination based dito sa figure na to. At i-express natin ay by Boolean expression. And the result that the generalized system is figure 7.1. Ito is kayang i-express sa expression. So, siyang OR at NOR input. So, A, B, C, D. Yung output natin Y1 sa OR. Yeah. Okay, so, siya is 4 input or /NOR gate. Okay? So, yung input variable may be available as only the number input. In that case, the complemented input is generated using inverter. So, ito yun. Nakikita niya. Meron inverter sa input. So, siya na ngayon is 4 input, 2 output. Combinational function. So, meron 2 wires na one representing normal literal and other representing the complement 1. So, ito yung B. I-represent ang complement 1 na wire kung may inverter. Okay? So, ito lang yan. Same lang yan. So, ito yung with normal. Ito yung complemented inputs. And then, ito na may sample nun. Nung may inverter. Up adder subtractor. Mamaya, itatak na. Sabi natin definition yan. So, based dito, ito yung kanyang combinational described na Boolean expression. Ito, based dito sa figure na to. So, yung Y1 is ito, yung AB yan. Okay? So, this Boolean expression needs both normal as well as complemented inputs. So, siya is half adder subtractor. And make A and B representing the 2 bits to added or subtract. Kaya siya, adder subtractor is adder subtracted ang ginagawa nito. So, mamaya, iyan na natin yun. So, ito ay introduction muna. So, implementing combinational logic. Ito ay self-explanatory. Siyempre, kapag nag-design ka, is state the problem, identification, the output, express the relationship, extract the truth table, write mo yung Boolean expression, tapos minimization Boolean expression sa okay. So, dito is yung minimization is pwede na Karnaugh map. And, siyempre, meron pa ibang method, pero ito lang yung focus. Yung the implementation should have minimum number of gates. Siyempre, kaya natin minimize para minimum number inputs at minimum interconnection para sa shortest time propagation at limitation lang ng driving capability ng gates. Okay? Dapat hindi nyo i-ignore. Kaya natin ginagawa itong minimize. So, dito na tayo sa arithmetic circuit ng basic building blocks. So, na-discuss natin combinational logic, building blocks that can be used to perform addition and subtraction. So, yung addition and subtraction is the most commonly used arithmetic operation kasi yung multiplication and division are respectively the process of repeating addition and repeated subtraction. Multiplication is repeated addition na, and division is repeated subtraction. So, sa basic building block is the form of basic or hardware used performed by four-set equation on binary number. Ito ay half adder, full adder, half factor, push, and control inlet. So, unahin natin half adder. So, sa half adder is used to add two bits such as circuit that has two inputs and represent two bits to add two outputs. So, one producing the sum output and the other producing carry. Sum and carry. Makikita mo sa video 7.4 yung truth table ng half adder. So, ito. So, AB, yung input, S is sum, and C is carry. Ito yung kanyang truth table. And then, ito yung kanyang logic implementation ng half adder. Siya is naka XOR and AND. Okay. So, dito, sa expression na to, ang sum and carry, makikita nyo dyan is, ayan, naka XOR and naka AND. So, the two expression tells that now go for the simplification. The first one representing sum output is that an XOR gate. Okay, the second one representing is the carry is an AND gate. However, two expression can be represented different forms. Siyempre, dahil various law and theorem of Boolean algebra illustrate the flexibility ng designer in hardware implementing as a simple combinational function. So, yung half adder, studied na Boolean algebra, how various logic gates can implement in the form either only NAND or NOR. Siyempre, kasi ng NAND and NOR gates are universal gates. So, pwede siyang simplest way to a hardware implement. A half adder will be used to input XOR para sa sum and 2 inputs sa AND to carry for the carry output. Siyempre, yung simplest way. Pero pwede mo pa rin siyang gawin na NAND or NOR gates lang. Kasi siyempre, siya is universal. So, dito sa sample natin is NAND gates only ang ginamit. So, sa close look at the logic diagram. So, yung XOR natin is ito. Ito siya. Ito katumbas na NAND gate ng XOR sa NAND gate. So, A, B, and then yung sum. At alam naman natin na yung NAND is ganito kapag kailangan mo ng AND gate. So, ito is yung NAND gates half adder. So, syempre, mas simple itong XOR ay AND. Okay? So, yun yung half adder. So, yung full adder is the circuit. We take circuit that can be used to add 3 bits. Kanina is 2 bits. Yan naman is 3 bits. Sum, may carry ulit, same. So, the full adder circuit overcome the limitation of the half adder. So, which can be used add 2 bits only. So, siya is 3. So, kapag 3 na, kailangan mo na ng full adder. So, let us record the procedure of adding larger binary number. We will begin in addition of LSB. The addition is this significant bit of the two number. We record the sum under the LSB column and take the carry. Any forward the next higher column bits. So, add the next adjacent higher column bits. We should be required to add 3 bits. There's a carry from the previous addition. So, itong sinasabi dito, ng full adder, ayan. Also, we reach the MSB. So, ito yung MSB, yung A, dito sa table na to. So, kung itong mga sinasabi dito na full adder is therefore essential hardware implementation of other circuit capable of adding larger binary number, a half adder can be used for addition of LSB. So, yung half adder is para lang sa least significant bit. Meron na tayong most significant bit, full adder na. So, ito yung diagram natin doon. AB, carry in, sum, at carry out. So, ito yung table. Carry in, ito. AB, then sum, and carry out. Ito, 0, 0, 0, 0, 0. Nag-1 yung carry in, meron tayong 1 sa sum. Nag-1 yung B, 1 sa sum. Etong B at carry in is 1, napunta siya sa carry out. Okay? So, nag-1 yung A, sum. Nag-1 yung A at carry in, meron tayong carry out. So, yan yung sinasabi rito na sa meaning na yan. So, based dyan sa truth table na yan, is mabubuo natin itong presyo na ito. Okay? So, usahin natin. Sa show the truth table, put other secret show order to arrive the logic circuit for other implementation of both other. We will first rewrite the full expression for the two of is exactly in terms of environment, right? So this expression is then simplified by using a simplification technique. Okay, so yun nga, implementing tayo dito sa step na to. Kasi sa step na yan, is construct the truth table. Meron na. Write the Boolean expression. Then, minimization no, yung Boolean expression. So, yung ating truth table. Ito ng expression. Yung ating makikita nyo rito sa yeah. Next step is to simplify the expression using time mapping. So, ito yan. 7.8. A, ito yan. So, kung ito yung A is yung sum, itong B is yung carry, siyempre kasi dalawa yan. So, carry. Yung A, ay yung sum is makikita nyo na wala nang sisimplify. Pero yung carry is nasisimplify pa. So, based dyan, yan, and is it clear from two maps, the expression of sum output cannot be simplified any further. So, yung carry out given by the equation na to, show the logic diagram of the full adder. Full adder can also be seen from compromise to half adder. So, pwede rin yung full adder is compromised by two half adder and an OR gate. So, yung sum and carry outputs can be write as follow. So, ito yun. Kapag kinompromise mo siya ng equation ng half adder. Okay? So, ito na yung ating sum. So, kapag sinimplify mo in Boolean theorem, ito na siya. Pero, siya is kapag na-kernel map mo naman, is ito ang ikalalabasan. Okay? Kung mapapansin nyo naman is, kaya siya sinabing pwede siyang ma-compromise ng two half adder. Kasi makikita nyo rito is, naka-parenthesis, is siya yung nasa half adder. Yan o. So, yung nasa half adder. A not B or A not B. So, yan. So, yung Boolean expression na 710, yan, 710 na to. Implement with two input XOR gate. Provide the one of the inputs is Cin. Explain lang dyan kung ano yung ibig sabihin ng Boolean expression. The other inputs is the output of the other two inputs, gate A and B, as its input, similar to Boolean expression 711, and implement by ORing two min terms. And of them is an AND and an AB. Okay, tama? The other also the output of AND gates whose input are Cin, carry in, and the output of an XOR operation on A and B. So the whole idea of writing the Boolean expression is modified form was to demonstrate the use of half adder in building a full adder. Okay? So para mas malinaw lahat ng sulat dyan is 7 710. So, ito pala muna yan. Ito yung logic circuit diagram ng full adder. So, ito yung sum, ito yung carry out. Okay? Ito ay full adder. Okay? So, yung half adder is ito ha. And then, ito. So, is full half adder na yan. Ito yung full adder. Yan. Pero ito yung sinasabi na may kinalaman yung half adder sa full adder. Tingnan nyo to. So, kung itong may square na to is yan yung itsura ng half adder na sinasabi doon na lalagyan mo lang ng OR gate. So, half adder and half adder plus OR gate is full adder. So, ito yun. Half adder, and OR gate is full adder. So, ito yung sinasabi doon. Na yung use of half adder circuit is the building a full adder. So, ito yun yung figure A, yung pinakita ko. So, redraw the portion of circuit representing the half adder replaced with the block. So, yung full adder of type described above form basic building blocks is binary adders. However, a single full adder secret can be used one-bit binary number only. Cascaded arrangement of this adder can be used to construct adder capable of adding binary numbers with larger number for bits. Example, 4-bit binary adder would require 4 full adder of the type shown in 710. Connected cascaded. The 711 show the arrangement are two binary numbers. Yung A0, B0 is the LSB at yung most significant in between. Mas malinaw? Ito yan. 4-bit binary adder. So A0, B0, full adder being SO. A1, B1, full adder, S1. And then dito yung carry in, then carry out. So yan yung diagram ng 4-bit adder. Okay? So yun ang about sa mga adder. So, half adder and full adder is may kinalaman sa isa't isa. So half adder is sa 2-bit and then yung 3-bit na full adder na ang gagamitin. So ganun din sa half subtractor. Okay? Pero dito naman is two given binary numbers can be carried out by adding 2's complement of the subtrahend to the minuend. Okay, so yung pinagkaiba niya. This allow us to do the subtraction operation with other circuit. So, pag ginawa mo yon, pero other circuit yung gagamitin. We will study the use of other circuit for subtraction operation in following page. Okay, mamaya makikita niyo yung other subtractor. So before that, we will briefly look at the counterparts, half adder and full adder circuit in the half subtractor and full subtractor. So we papakita rito yung direct implementation of subtraction operation using logic. So simulan natin sa half subtractor. A combinational circuit can be used to subtract one binary digit from another to produce a difference. Saka borrow out. Kanina is sum and carry. Ngayon is difference and borrow. So yung borrow, specify whether one has been borrowed to perform the subtraction. The truth table of the half subtractor is nasa figure 712 para ma-explain further at ito ang kanyang equation. Kung makikita nyo na yung difference natin and yung sum kanina is iisa. Pero yung borrow is naka-complement. Okay? So makikita nyo dito is ito. So yung difference natin is ito and then yung borrow and then ito. 0, 0, 0 difference. So, 0 di borrow. So, yung 0, 1. So, meron tayong 1 na difference. So, may borrow 1. Okay? So, yung 1, 0, may 1 na difference, walang borrow. And then, yung 1, 1 is 0, wala siyang borrow. So, siya is naka-base dito sa kanyang expression. So, ito naman ang kanyang diagram ng logic. So, ang pinagkaiba niya is merong inverter sa A. Ang pinagkaiba niya sa half adder. So, sinasabi rito na gumamit din ng XOR gate. And then, yung borrow naman ay AND gate. The same. Pero yung A is complemented before it is fed to the gate. Yun, yung inverter. So, the logic implementation of the half subtractor. Okay, makikita nyo sa 713. So, ito yun. So, comparing mo yung half subtractor with half adder, we will find the expression for the sum and difference output are just the same. So, same lang. Pero yung borrow is similar to what we have carry in the case of half adder. Yun nga lang is yung A, that is the minuend is complemented siya. And AND gates can be used to implement the borrow output. Okay, so similarities between the half adder and half subtractor. Yun yung similarities na pwera lang yung uh, minuend is naka-complement. So sa full subtractor naman is same din. Operation on 2 bits, minuend and subtrahend also take into consideration whether one has already been borrowed by a previous adjacent lower minuend bit or not. So dito, there are 3 bits to be handled at the input of a full subtractor, namely 2 bits to be subtracted and borrow bit designated as borrowed in. There are 2 outputs, siyempre, difference and borrow pa rin. So yung borrow bits tells whether a minuend bit needs to borrow a 1 from the next possible higher minuend bit. Dito, makikita niyo rito yung kanyang Boolean expression at ang kanyang truth table. Makikita niyo rito yung minuend 0, yung A, subtrahend, yung B, yung borrow in, difference, and borrow back. So, dito tayo sa minuend and subtrahend, 0, 0, 0, 0, 0, 0, 0, 0, 1. So, may borrow in, so may difference, and may borrow out. So, nung walang borrow in, pero may subtrahend na 1, may difference tayong 1, tapos may borrow 1. So, may borrow, may subtrahend na 1, may borrow in, 0 difference, then borrow 1. Okay, so naka-base yan dito sa expression or vice versa. So, kapag yan ay ito ay natin, simplify ulit. Nakikita nyo na wala ng simplification yung na simplified form yung kanyang difference. Pero yung kanyang borrowed in is merong simplified form. So ngayon, ito na yung ating simplified form ng borrowed out. So makikita nyo rin dito na kinalaman yung half subtractor sa full subtractor. So, half plus half, tapos meron ulit OR gate, same sa kanina, is makakabuo ka ng full. Okay? Half, half, saka may OR, full. So, yun ang kinalaman niya sa half other. So, ito yon. Sinasabi rito na this expression, we find the expression difference output B is the same as the sum output. Also, the expression of the borrowed out is similar to carry out. In case the half subtractor, the A is complemented by the similar analysis, it can be shown that full subtractor can be implemented with half. Okay? So, yan yung sinasabi ko. So again, one full subtractor can be connected in cascaded to form subtraction on two larger binary number. Okay, so tulad sa kanina, pwede mo siyang gawing marami na cascaded form para mag-subtract ng 4-bit subtractor kasi siya is laging 2-bit lang. So siya ay 2-bit lang. So AA na 0 is full subtractor, mayroon siya isa, barred in, tapos barred out, same din. Ito is 4-bit. So, yung half subtractor and half adder is bali 1 bit. 1 bit. Kasi, ano lang yan, ganito lang yan. So, ito is, dalawa. 2 bit, okay? So, ito naman yung about naman sa controlled inverter. So, a controlled inverter is needed when an adder is to be used as subtract. Controlled inverter is needed pag gagawin mo adder is gagawin mo siyang subtractor yung adder. gamit like control inverter kasi makikita niyo naman dito na may inverter lang yung subtractor. Tapos, pag tinanggal mo yun is other na siya. So, kaya kailangan natin ng mode inverter. So, dito sinasabi lang na alam naman natin na yung XOR is kapag ganito yung kanyang setup na meron tayong 1 sa isang gate and then yung input mo na A is magiging inverted na siya. So, yan. Nasa exam naman yan. So, kapag binuo mo siya, is ito. Isa kang controlled na 1-0. Controlled na gate. Then, yung input. Then, yung output. So, ito yung 1 bit. And then, ito yung 8 bit. Okay? Na itsura ng controlled inverter. So, ito na yan. Yung other subtractor. So, ito yung other is gagamitin mong subtractor. So, yung subtraction of two binary numbers can be accomplished by adding two complemented as and complement of the subtrahend to the minuend and disregarding the final carry, if any. If the MSB bit is the result of addition is 0, then the result of addition is the correct answer. If MSB bit is 1, then implies that the answer has a negative sign. The true magnitude in this case is given 2's complement of the result of addition. So your full adder can be used to perform subtraction provided we have the necessary additional hardware to generate 2's complement and subtrahend and disregard the final carry or overflow. So show us such a hardware arrangement that as you perform subtraction of two perfect binary numbers. So, dito, yan. Yung sinasabi dyan is, dito is kailangan natin ng additional hardware para yung other is maging 4. Para mag-generate kasi ng 2's complement. Na yun niya is, ginagamit ay yung inverted high control inverter. So, dito is sinasabi, for implementing 8-bit adder subtractor, we will require 8 full adders and 8 2 input-output XOR gate. So, dito yan. And then 4-bit full adders is quad input XOR gate individually. Available in integrated circuit form. So, ito is commonly used natin is yung 4-bit adder. In TTL family is the type number 74. Sa TTL, 7483. And yung 7486 naman, yung quad 2 input XOR gate. So, ito naman yan, XOR gate, ginagamit na. Ito external. Kung itong 7483 is yung other, ito ngayon yung external niya na control inverter na 7486. Para makabuo ka ng other subtractor circuit. Ayan. 4-bit other subtractor circuit. Okay? So, ayan yung nasabi na yung other mo is gawin mo subtractor dahil sa tulong ng control inverter. So, dito naman, yung BCD other is yung kanya is yung possible 4-bit binary used to perform the addition of BCD number. Okay? And then, the BCD number. So, The BCD number is binary coded decimal. And then, so yung 000, blah, blah, blah. Yan ay 0 to 9. So when we set out to add two BCD digits, we assume that there is an input carry 2. So the highest binary number that we can get is equivalent to decimal number 19. Decimal number 19. Yun yung the highest binary number na nakukuha. So this binary number is going to be a 10011. On the other hand, if we do BCD addition, we will expect the answer to be 001100. Okay? Same yan. Expected. So if we restrict the output bits to the minimum required, the answer in BCD would be 11001. Same lang siya. 0. Ay, tatlong 0. So the table in 7.1 lists the possible result in binary and expected result in BCD when we use 4-bit binary adder to perform the addition of two BCD bits. So it is clear from the table that as long as the sum of the two BCD digits remains equal to or less than 9, the 4-bit adder produces the correct BCD out. So hanggat ano daw, hindi daw less than and equal to 9, the 4-bit adder produces the correct BCD output. So the binary sum and BCD sum in this case are the same, pag equal or less than 9. It's only when the sum is greater than 9 that the two results are different. Can also be seen from the table that the decimal sum greater than 9 or the equivalent binary sum greater than 1001, if we add 0110 to the binary sum, we can get the correct BCD sum. And the side carry out to 2. So, yan, sinasabi rito. So, para mas malinaw, makikita nyo ito sinasabi nyo. Binary sum saka BCD sum. Okay? So, sa binary sum is may K. Ito yun. K plus Z3, Z2, yan. So, correct needs to apply whenever K is 1. Right? It takes the last 4 entries. Also, the correction needs to apply whenever both Z3 and Z2 are 1. So, dito, kung makikita nyo, sa 1 to 9 is same sila. Ang BCD sum saka binary sum. 0, 1, 0, 0, 1, 0, 1, 0, 0. Okay? Same. Pagdating ng 10 is dito yung ano na siya? 0, 1, 0, 1, 0. So, dito sa BCD sum is ano na siya? 1. Okay? Kasi, ayan, 1 na dito sa carry. So, naka-carry ka na ng 1. Pero sa 11 is 0, 1, 0, 1, 1. So, yan, tuloy-tuloy lang. Ito naman is yung naka-carry ka na ng 1, saka nag-start ka ulit ng 1. So, nung nag-carry ka, yun yung 10. So, 10 plus dito. Dito na yung 1. And then yung 12. 13 naka-carry. Okay, pero dito is the binary sum is as usual. 1, 1, 1, tapos and then 1 dito, then 0, 0, 0, 1, 0, 0, 0. So, yan yung nagkaiba ng binary sum kapag BCD. So, for the remaining two entries corresponding to the decimal sum equal to 10 and 11, a correction is applied for both Z3 and Z1 being 1. Okay? So, while the hardware implementing 0, 1, and 0 can be added to the binary sum output with the help of second or bit binary adder, correction logic is dictated by the Boolean expression 7.7 method. So, ito yun. Truth table na to. Okay, yun yung sinasabi dyan about sa BCD. Okay, so ito yun. So, may 4-bit binary tayo. And then 4-bit binary other. Carry in. Ayan. So, ito yung BCD1 mo, BCD2. So, ayun yung K. Dito sa formula ng Boolean expression na yan. Then, ito na yung carry. Okay? So, single digit BCD other yan. Okay? So, pag 3 digit, giging ganito na siya. So, yung 0 to 3, i-add mo sa B0 to 3, nakaroon ka ng S0 to S3. Pero yung A4 mo, B4 to B7 is another BCD other kapag 3 digit. So, ang kaya niya lang dito is 4-bit binary other. So, ito yun. So, itong BCD other na to is itong buo na to. Okay, so yun yung carry in. Yan, carry in. Then, carry out. Okay? So, same din. Kung may other, meron ulit OR gate dito. And dito yung carry. Okay? Okay. So, sa sample naman dito is yung half other, meron tayong input na AB and plot the corresponding sum and carry of the same scale. Okay? So, ito the other given. Ito daw yung input natin. May 1, 0, 1, 0, 1. Okay? So, dito naman ay 0, 1, 0, 1, 1, 0. Okay? So, yung solution dyan is, alam naman natin na knowledge of truth table of half other is all we need to remember to solve this problem is yung 0 or 0 is 0. Siyempre, yun yung sum. And a 0 as the carry based dun sa ating truth table ng half other. Okay, so yan is yung 0 o 1 o 0 is 1. Siyempre, yun yung sum ulit. And then 0 yung carry doon. Yung 1 or 1 is 0, yun yung sum, pero may carry tayong isa. So, yun yung sinabi lang dito yung table. So, nangyari na yan is yung 1 sum output is kung 1 and 0, syempre 1. So, yun, sum. 0 daw yung carry. So, 0. Yan. So, yung 1 and 0 ulit, edi 1 ulit yung sum, and then 0. And then yung 1, ayan, 0, and then so on and so forth. It is 1, and then 0. 1, 0. Okay? So, ito, sinabi lang dito yung nasa table na half other. So, balikan natin para sa half other. Ito yan. Pag 0, 1, 0, 1, 0 yung carry. Ay, hindi yan. Full other pala yan. Half other lang. Ito. So, 0, 0, 0, 0, 1, 1 yung sum. 1, 0, 1 yung sum. So, 1, 1, and then may carry kang 1. Yung sinasabi dyan sa sample number 1. Sample number 2 is relevant expression, half adder and half subtractor circuit is design daw ng half adder subtractor circuit can be used either sa addition ng addition or subtraction on to 1 bit number. Okay? So, solution. Half adder and half subtractor daw. Ito, alam naman natin. Half adder, half subtractor. So, if we use controlled inverter, siyempre, gagamit tayo nun para maging adder subtractor. A, in the case of half subtractor circuit, so dito sa half subtractor, yung A daw, then the same hardware can be used to add to 1-bit number, figure 725 shown, logic circuit diagram. When the control input is 0, the input variable A is passed and complemented to the input of the NAND gate. In this case, the AND gate generates the carry output and addition operator of the XOR generates the sum. On the other hand, when the control input is 1, and the AND gates generate the borrow output and XOR gate generates. Okay, so sinasabi lang dyan is ito yung design natin. Siyempre, sinabi na to doon. Pinahaba lang. Gumamit siya ng controlled inverter. Gamit yung other, ito, XOR, and NAND. Diningitan niya ng controlled inverter sa gitna kasi kung di subtractor lang, is fixed inverter dapat yan. Pero dahil gagamit ka ng add, other, and subtractor, is controlled siya. So, you control 0 and 1. Sinasabi lang dito na when your control input is 0, so yung input variable is passed and complemented. So, ibig sabihin, ang lalagay mo dito is 0. Kaya mo siyang makomplement. Tama na yung 0. Okay? Tama yan. So, in the case, the AND gate generates the carry output and the XOR generates the sum output. On the other hand, when the control input is 1, so the borrow and the get then 0 at the control takes the half other and 1 and takes the half subtract. So, kapag 0 yan, other siya. Pag 1 siya is subtractor siya. Kasi na-activate yung inverter. So, yun. Yun yung about sa ating topic ngayon, arithmetic circuit. Half other, full other, half subtractor, full subtractor, controlled inverter, BCD other. So, yun. May question ba kayo? Kaya kong sagutin? Guys, nandiyan ba kayo? Guys? Nandiyan ba kayo, guys?
Yes, sir, dito po.
Ayun. Any question? Engineer? So, half other. So, in-explain ko lang kung paano nag-a-add and subtract gamit yung logic gates na pinag-aralan natin. Dahil sa future is may kinalaman din niya sa microprocessor. So, tackle lang natin mga basic fundamentals para kahit pa paano nagigets kung paano gumagana yung processor. Yung iba guys, mga engineer, wala kayong question? Clear ba? Clear? Clear naman? Kahit
Clear
paano?
po. Clear po.
Okay, salamat. Engineer Gatchalian. Wala naman. Okay. So, walang mic si Engineer Mati. Okay, sige. So, pakicheck na lang sa ating Canva yung about sa lab natin. May mag-lab, may lab tayo. Pakicheck na lang kapag available na. Baka di ko masabi na meron ako may post. Check na lang. Meron tayong lab. About lang sa na-discuss natin ng prelim na loop. So, ayun. Para lang meron pa yung lab. So, okay, kung wala ng question, so sige. Tayo. You're taking, guys. You're taking. Naman kayo. Question pa na to? So, sino? May trono ngayon para sa video. Yung hindi naka-cellphone. Wala. Sige. Mukhang nagbo-volunteer si Engineer Miles. Salamat sa iyong pagbo-volunteer.
Sige po.
Sige.
Sige, picture na tayo, guys. 1, 2, 3. Isa pa. 1, 2, 3.